The second compartment contains the mixer tuned line, which also acts as a coupling device and is placed physically close to the window between compartments 1 and 2. This compartment also contains a diode, which acts as the mixing device, a capacitor which is connected between the anode of the mixing diode and the compartment wall, and a coil which is placed between the anode of the mixer diode and the UHF intermediate frequency output. The second compartment represents the mixer stage of the UHF tuner. The third compartment contains the UHF oscillator circuitry. It is basically a modified form of the Colpitts oscillator configuration called the Ultra Audion. Notice that this circuit uses the silicon epitaxial planar transistor as the primary active component of the oscillator stage. This stage also contains a trimmer capacitor used to adjust the oscillator frequency for channel selection. Also notice the electromagnetic coupling between the oscillator stage and the mixer diode. The capacitors mounted on the metal enclosure are used to reduce unwanted AC frequencies. Now let's see how this circuit works. As the incoming RF signal strikes the antenna, a signal is produced across the antenna input coil. This RF signal is then electromagnetically coupled to the tuned line coil in the first compartment. As you may have noticed, the tuned line coil is in series with the first of 3 gang-tuned trimmer capacitors. The tuned line and the series trimmer capacitor form a tuned resonant circuit. This is the first part of the channel selection circuitry. The selected RF signal is then passed through the window which separates compartment 1 from compartment 2. From here, the signal is electromagnetically coupled to the mixer tuned line coil. Notice that the mixer tuned line coil is also in series with one of the 3 gang-tuned trimmer capacitors. This tuned resonant circuit assures that only the selected channel will be allowed through to the mixer stage. The mixer diode then combines the UHF oscillator signal with the selected RF signal. The selected RF signal is inputted through the coil attached to the anode of the mixer diode. The UHF oscillator signal is electromagnetically coupled to the cathode of the mixer diode. The result of the combined signals is the difference frequencies which are outputted through the UHF intermediate frequency output connecting point. The 2 IF frequencies at the output of the mixer stage are 45.75 MHz for the picture carrier and 41.25 MHz for the sound carrier. You should have noticed that the UHF oscillator stage contains the third of the 3 gang-tuned trimmer capacitors used in the channel selection circuitry. This trimmer capacitor is used to control the output frequency of the oscillator stage and is designed to operate at a frequency higher than the incoming RF signal. The frequency of the oscillator stage is adjusted so that when the incoming RF signals and the higher oscillator signal combine, they will produce an intermediate frequency of 45.75 MHz for the picture carrier and 41.25 MHz for the sound carrier. We will now pause for a short review of the material just discussed. The UHF tuner consists of 3 primary sections. These are the preselector, mixer, and the UHF oscillator sections. The preselector portion of the UHF tuner is used to select the desired channel, block out all unwanted channel frequencies, and isolate the oscillator section from the antenna. The mixer portion of the UHF tuner is responsible for combining the selected RF signals with the signal produced by the UHF oscillator section. The oscillator section of the UHF tuner is designed to operate at a frequency higher than the incoming RF signals by an amount equal to the IF frequency values. The IF, or intermediate frequency values, at the output of the mixer section will be 45.75 MHz for the picture carrier and 41.25 MHz for the sound carrier, regardless of the frequency of the selected channel. This concludes review number 1.